Okay, let's dive right into this explainer. Today, we're going to completely demystify the world's fastest growing and most popular programming language. Seriously, whether you're an aspiring software engineer, a data analyst, or honestly just someone looking to automate some of those boring daily tasks, Python is absolutely the ideal language to learn first.
Just to grab your attention right out of the gate here, $115,000. That was the average salary of a Python developer in the US back in March of 2018. And, it's only grown since then. It really just proves how lucrative this skill can be. The demand for Python is completely off the charts right now, offering a really solid, high-paying career path.
And when you actually look at the code, it brilliantly illustrates exactly why beginners love it so much. Think about this. If we want to just extract the first 3 characters of a text string, older languages like C or JavaScript require this super messy, complex syntax. But in Python, it is so clean and simple, it reads almost like plain English. You don't have to stress over complex memory management. You literally just focus on the logic.
So, here's our roadmap for today. We're going to treat learning Python like gathering building blocks. We will cover why learn Python, variables and data types, operators and conditionals, automating tasks with loops, reusable code using functions, and finally, building CLI mini projects.
Let's kick things off with Section 1. Why learn Python? The world's most popular language. Let's see why it's the perfect first step to unlocking those high-paying opportunities. The real secret to Python's massive dominance? Efficiency. Because Python lets you solve complex problems in way less time, and with far fewer lines of code than other languages, it's been rapidly adopted by the absolute biggest companies in the world. We're talking Google, Spotify, Dropbox, Facebook. It's a multi-purpose tool that they use for basically everything, from AI and machine learning all the way to software testing and web development.
Moving on to our actual foundation, let's hit Section 2, variables and data types, the labeled boxes of programming. So you can think of a variable as simply a labeled box where we place our data, so we can easily find it and reference it later on in our code. Let's say you want to keep track of a user's name, a student's age, maybe a product's price. Well, you create a variable. It acts as this friendly, human-readable label that points directly to a specific spot in the computer's memory. Now, inside those labeled boxes, we store what are called primitive data types. We've got integers for whole numbers, floats for decimals, strings for text, and booleans, which are simply true or false values. And it's absolutely crucial here to use meaningful names for these variables. Format them in lowercase letters, put underscores between the words. If you do that, your code is going to read beautifully, kind of like a clean, well-written newspaper article. Okay, what's really fascinating here is this concept of falsy values. While a Boolean is strictly the word true or the word false, Python will actually interpret certain other values as effectively false when you use them to make decisions. So things like the number 0, completely empty strings, and a special object called none, those are all considered falsy. Basically, anything else, like the number 5 or a string with actual text in it, evaluates as truthy.
All right, now that we have our data stored in those blocks, let's move to Section 3, operators and conditionals, giving your code a brain. We use comparison operators to actually evaluate our data. We have operators to check if values are equal to each other, not equal, greater than, or less than. And the cool thing is, checking if one value is greater than or equal to another will always, without fail, spit out a true or false Boolean. This is exactly how the computer starts to understand the state of the data it's holding.
Now, when you want to string together multiple conditions, you use logical operators like AND as well as OR. And this brings up a brilliant concept called short-circuiting. See, the Python interpreter reads these conditions from left to right. If the very first condition makes the final result totally obvious, like say an AND statement hits a false right away, the evaluation just stops immediately. The computer literally doesn't even bother reading the rest of the line, which saves you highly valuable processing time.
So the crucial takeaway is that by combining your comparison operators with conditional statements, using if, elif, and else blocks, you're basically giving your program logic. You're allowing your application to seamlessly decide, for example, if a loan applicant has a high enough income and a good enough credit score to be eligible, or if they should be rejected. Your code literally branches out based on the truth of those conditions.
Let's stack our next building block with Section 4, automating tasks with loops, the engine of repetition.
Frankly, loops are the fundamental reason we even use computers in the first place, right? Automation and doing repetitive tasks at lightning speed. Imagine you want to say hello 10 times. Sure, you could manually type the exact same print statement out 10 times, but man, that is incredibly inefficient. Instead, a for loop lets you iterate over a sequence automatically, letting you execute a block of code repeatedly. It completely streamlines your scripts and gets rid of all that manual labor. But don't worry, you are always in control of these loops. Say you're searching a massive list for a specific user and you find them on your very first try. You definitely don't need to keep searching. You can use a break statement to jump entirely out of that repetition cycle the second your goal is achieved. Or you can use continue to just skip the current step and jump right to the next one.
Aside from for loops, we also have while loops. These will repeat a task as long as a certain condition remains true. But listen, you've got to be incredibly careful here. You always need to provide a clear exit strategy in your code. If you don't, you might accidentally create an infinite loop that evaluates to true forever, running constantly until your poor machine runs out of memory and just crashes entirely.
Next up, let's look at Section 5, Reusable Code Using Functions, the blueprints of your app. As your programs eventually grow to be hundreds of lines long, you are absolutely going to need these to stay organized. You can think of a function sort of like the specialized buttons on your TV remote control. When you press the volume button, it carries out this highly specific background task perfectly. And the best part? You don't need to understand the complex electrical wiring inside the remote to use it. A Python function does the same thing. It lets you group complex code together under one simple name, and you can fire off that code over and over with just a single, simple call. Now, one of the biggest points of confusion for beginners is the terminology around how we pass data into these functions. Just try to remember this simple distinction. Parameters are the empty slots or placeholders in your blueprint when you first define the function. Arguments, on the other hand, are the actual real-world pieces of data you plug into those slots when you finally execute it. And hey, here is a massive tip that will honestly save you hours of debugging. In Python, all functions return a special none object by default. If you write this beautiful, super complex function to calculate a math problem, but you forget to include the return keyword at the very end of it, your program is just going to hand you a none object, effectively keeping that mathematical answer a total secret from the rest of your code. So always remember to return your values. Finally, let's move to Section 6, Building CLI Mini Projects. The payoff. This is exactly where all that theory turns into reality. By simply combining the variables, conditionals, loops, and functions we've just talked about, you are already fully equipped to build command line interface applications. Seriously, just those few concepts allow you to build a fully functional calculator, an interactive number guessing game, a daily to-do list, or even a secure password generator that spits out data directly to your terminal. It's pretty amazing when you realize that even the most complex software in the world is really just these simple foundational concepts: variables storing data, if statements making decisions, loops repeating actions, and functions organizing it all, stacked right on top of one another. You've got the blueprints now, so I want to leave you with this exciting thought. What are you going to build first?